I think I made a mistake. It was either on this class or on the other class last week, and I didn't hit record. And then also on the JavaScript class this week, I didn't record it. And then after class, I went through all the steps on that class and recorded it, but it only recorded my video, so I had my face while I'm talking and typing code, and so it was totally useless, frustrating. But I hope to figure out how to get through these little technical difficulties. All right, Firoz is waiting to be admitted again, and I click it like 100 times until it finally goes in. All right.
Where are you from, Aaron?
I am in Montana.
Montana, okay.
Where are you?
I'm from Colombia right now.
Oh, Colombia, all right. For some reason, I thought you were from Spain.
Okay.
And not just your name. I thought I saw that like on your LinkedIn profile or something. Feroz, did you make it in?
Yeah, hi, Aaron.
All right, hi. You? Good. Sorry about that needing the invite. I need to figure out more about LinkedIn meetings so that everyone can join without the difficulty. Yeah. We'll go ahead and get started. I know it's just the two of you right now, but you know, I'm making the recording and we'll post it online. Hopefully we'll get, I think it's these little things that's making it hard for people, whether it's the meeting invite or the Zoom link. Anyway, so let's get started. I just sent you guys an email about an hour before class. Did you see that? That talked about what we intend to do and what you should have set up. So I'm going to quickly go through setting up Conda. I'm not going to reinstall it. You can see, so I have my Conda environment. What is it? I think it's just deactivate. So if I want to go out of my Conda environment, I click Conda deactivate, right? And then I can do Conda environment list, and it'll show which environments I have. I have the base environment, which is the Python 3.7. And then I have the training environment, and I can do like Conda remove name. I don't need this, whatever.
Sorry, Aaron, I can see just the Conda.
Oh, just the Conda cheat sheet? I wonder why that is. That seems to be a glitch. So desktop 1, okay. You see the cheat sheet. Now do you see my terminal?
Yeah.
Okay, great. And I switch back and forth, and it continues to go back and forth. Great, okay. So I just want to list my Conda environments. And you can see I have these example ones that I set up. So I just want to remove. So I can do Conda remove dash name or dash n, this whatever environment, and my environment. And I'm just going to go through the process. So both of you, do you have Conda installed? So you open up a terminal and you get Conda?
Yeah.
Okay, great.
I've installed that. Yeah.
Okay, great.
I have a question, Aaron. What's the difference between Conda and Mini Conda? Is lightweight version of
So yeah,
Conda?
Anaconda is the full distribution. It downloads and installs all the libraries. If you're on Windows, are either of you on Windows?
Yeah, right now I'm Windows.
Okay. Well, on Windows, if you install Anaconda, it's going to install all the packages, all the data science libraries and stuff automatically. Not all, like 150 packages or something. Mini Conda just installs the base package and the Conda package management tool. So that then you would need to do things like, you know, do Conda install whatever, right? So if I want to Conda install Numpy, which is what I want to do, then I would do that. But I want to do it in a particular environment, a virtual environment, like you would use PyM for. And I'm not going to do that right now. I'm going to wait to do that in just a second. So I can see my Conda environments, and I have this training environment. I'm going to create one. I'm just going to call it data science, right? So, and I can do Conda environment help.
Aaron, just
yes.
to, sorry for interruption. I
Go
just
ahead.
wanted to confirm around this PyData book
Yes.
Because I can see it's totally different for me whenever I open that Anaconda.
So you go to the PyData
So
book?
that, no, I've simply opened that Anaconda prompt, Miniconda.
Yeah.
And there I can create the environment, and
Yeah.
I have activated an environment. But the screen is totally different for me. Like you get a black screen like prompt Chrome, which is the general one. But for you, I think it's different. Which version you are? Just wanted to confirm that.
So I'm on a Mac, and I'm just using my terminal now. The background and stuff is just whatever custom font and background color I have set up.
Okay,
but the text that you write should be the same, right? So you can do Conda environment create, and I'm just going to call this one data science.
Yeah, got it. Yeah.
And this is only going to take, maybe it's just Conda create. I think it's like alias. Yeah, Conda create data science. And it's going to say proceed. Takes just a second. Now, to activate it, in other words, to start using this is a virtual environment, which allows me to essentially freeze and specify a specific version of Python. So when I say which Python, and on Windows that might not work, and I'll see my Python version. And then I can Conda list, and it'll show what packages I have. I don't have any packages installed. You can see here, do you have, at the start of your prompt, you should have parentheses. If you did Conda activate your environment, you should have that environment in parentheses in your prompt. And so what I can do then is I can do Conda install, and the first thing I want to install is Jupyter. And I hope you've got this set up, because this can take a lot of network time to install that. And it's just going to install all these resources for the Jupyter notebook. These are all the dependencies for Jupyter. So it will take a little while to install. And so what I thought I'd do while that's installing is hop back over to the cheat sheet and show you a few things. There we go, I'll make that a little bit smaller. So Conda environment list, or Conda list for the packages. You can install a package with Conda install. What we just did, we did Conda environment create. You can actually specify a file, which is like using your requirements.txt for pip. This text file is a list of all the packages you want. You can search for a package and so forth. So here's what we're doing right now: Conda installing Jupyter and all of its dependencies. And Anaconda takes, and it's essentially an alternate Python distribution with also its own package repository. But you can think of Anaconda as like a Red Hat or an Ubuntu of, those are Linux distributions, but Anaconda is a Python data science distribution. They maintain compatible versions of all the different packages and to match different versions of Python and test them. So we have that. Now here I can go which Jupyter, and you can see when I launch Jupyter, it will go to my mini Conda environments, my data science environment, bin Jupyter. And actually I don't have pip. You can actually use pip from within Conda. So if you like using pip, you can do Conda install pip. And then you can use pip to install packages that may not be in the Conda distribution. But then let's just go to the PyData book. Did you guys both have this installed at github.com/wesm/PyDataBook? I pasted that into the chat. So you can either just download it. I'm going to make this smaller so I can see the chat as well as the download. So you can either git clone or just download the zip file. So that's what I'm going to do is I'm just going to grab this. And I'm already in my PyData book folder. I can go to like temp, and I can get clone PyData book. Oh, it's already there in temp too. Okay. We'll just pretend that worked. That was probably from last week where I did that. Okay. And then I can, that doesn't look like it has it all. Let me go back to here. Data Science Python, PyData book. Okay, yeah, so it has all these chapter 2 IPy notebook. And that's what we want to do. So when I'm in the PyData book directory, then I just want to type Jupyter notebook. Like so. And what this is going to do is it's going to launch a web server which runs Jupyter, and Jupyter is the notebook. There's actually a cooler new version of Jupyter that isn't just like a notebook. I think it's called Jupyter Workspace. Yeah, Jupyter Workspace is kind of like an online IDE. But we won't get into that right now, since really what we want to do is just follow along with the text. So once we have everything going, we want to go ahead and open up the chapter 2. Chapter 1 is all setup stuff, and there's not a notebook for it. Looks like it's taking a while for this to load. All right, there we go. So we've got here our Jupyter notebook. It has the menu across the top, file, edit, whatever. So I can open a new notebook. I can copy it. I can, cut and paste, whatever. But what we're going to do is we're going to read along with these examples and execute them. And the easiest thing to do is to note, you can see here I made a change here. Yours probably doesn't have this print hi there. But if you click into this first example, where it says import NumPy, click there, and then you go up to the top and you click run. You'll get an error like this. And the reason I went through this exercise is to make sure if you get an error, module not found, well, no module named NumPy. Why is that? Because in this new environment that I just created, this data science environment, hop on over here, create a new terminal. I'm going to do Conda, activate data science. And I'm going to do Conda list to list my packages. Well, I have all these packages, but you can see I don't have NumPy installed. I've got everything from Qt to zlib. So what I'm going to do, I'm in this environment. And what I want to do is I want to do Conda install NumPy. I could actually even do that. I'm not sure if I can do that from the Jupyter workbook. I can do it from the Jupyter workspace. But once it installs NumPy, you can see there's some dependencies. I just clicked yes to accept those and installed all these dependencies, NumPy, MKL, all that, libg, Fortran even. And now I can run. Now it succeeds. You can see it executed and didn't cause an error. Now I can also type in this gray box. This is essentially a Python interpreter mixed with documentation, right? I can do print hello Jupyter. And when I run that, then it shows my output, hello Jupyter, right here. So that's all it is. You see also we have in3. So it uses Ipython as an interpreter for the Jupyter notebook. And the next thing I want to show you is Ipython from the command line. So again, I'm going to do Conda list and show that Ipython was installed with Jupyter when I installed Jupyter. If you don't have Jupyter installed and you want Ipython, you can just do Conda install Ipython, and it'll say it's already installed. Same thing if you use pip or pipenv or pyenv, you can do pip install Ipython. Conda and pip are roughly analogous. The difference is that pip can only install Python packages. Conda can also install external dependencies like C libraries or web servers like the one running Jupyter. So all requested packages are already installed for Ipython. So now from the terminal, I can type Ipython. And last week I showed how to use bpython and was getting some funky output for that. Ipython and bpython are essentially wrappers around the Python interactive shell, the Python REPL. So I can do print hi here. And what I wanted to point out is I have this in1, in2. That's my inputs. And my outputs are, right, I can do foo equals 10, and then foo by itself. It will do an output 3. So Ipython is an interactive shell. You notice a couple things above and beyond the Python shell. It has, you know, this array of inputs. For instance, I can say in 1, and it will show me what my first command is. So this is like a command history. I can also show you, or I can also look up out 3, for instance, which will print 10 again. And there's some magic commands like history, and it'll show me my list of input commands. And I can also refer to the previous command, which will execute the previous command before that. I can also execute 2 commands previously, which is now the same one. In other words, right, I did out 3, printed 10, and then I did, so 2 back. I can even go 3 back. Here, let me, oops. That's the other thing you might notice. Oops, I mistyped something. I can go back. I can actually even, I can even do multiple lines. It automatically indents. I can print I. And I can even go back and go up multiple lines and change that and execute that. So now it went from 2 to 8. I can hit the up arrow, which is for you on Windows, it's like DOS key, where you can go back to previous. I can go back, print my previously executed sequence of commands, and I can change that to whatever I want here. So that's kind of cool that Ipython is this interactive shell that is somewhat more friendly than the default Python shell, right? Which is just black and white. It's like a terminal. So that's some cool things of Ipython. I can also do some other things. I can use a % to run a shell command. So for instance, I can do an ls on my directory, or if you're on Windows, I don't know if you do dir, that would work. But now you might notice that if I do magic, it'll show me all the magic commands that are available. And it'll also say, in this case, that my magic commands are automatically done. So I can do Conda install Selenium, for instance, and it will run that. I could, what it does is it says, if it's a %, execute it as a magic command or execute it as a shell command. Like a shell command, I can also execute with an ampersand. Before the command. So for instance, I can do start or ampersand ls or ampersand present working directory, and I'll show you those things. But because it has these magic commands automatically enabled in this Ipython session, I can do those without, actually pwd won't work, but ls does work. Oh wait, pwd did work, never mind. Okay, that's present working directory, by the way. So you can use this Ipython shell pretty coolly from the command line. There's some other features of this, like, well, I'll get to that in a minute. But for instance, the help, right? So I can do help ls, and help is built into Python. Well, ls doesn't work. Help print is what I want. I can see the help documentation or the doc strings for it. I could create a function, right? I can call my function foo, and I can create some documentation. It prints foo. That's my documentation, and print foo. There's my function foo. It's an awesome function. That's all it does. But I can also do help foo, and it will tell me, you know, my doc string here for that. Now with Ipython, you can actually do it another way. I can go to foo ? And it will just print it like that. I can do foo ? 2 question marks equals show me the source. So then it prints out def foo prints foo print foo. It shows me the source of this function. You can even do this on built-in stuff. So I guess that's not going to print the source, but it still prints the documentation. So some cool things that you can do with Ipython. But let's get back to Jupyter. I just wanted to point out that Jupyter is using Ipython behind the scenes. The Jupyter notebook executes these code sections, and we can actually even, so I can insert a cell down here. This is just showing you can use the Python interpreter, or you can use the Ipython interpreter to do that. And it shows you can do this magic command, run hello world.py. So I could actually hop in over here, and I'll create that. I'll create hello world.py. I've already got it written, actually, because I went through this. It prints hello Python. Now from the command, I can do Python hello world.py. Nope, mistyped it. And it executes, no surprise there, it executes my file as normal. In Ipython, I can stay in my shell and I can run hello world.python. Oh, and that's the other thing I want to show. It will also do tab completion. So I got HEL, and then I hit tab. It completes to hello world, and it runs that. It can do the same thing for imports. I type NUM, and I hit tab, and it gives me these. It gives me this option. I can select numbers or NumPy. So that's pretty cool. I can even do import NumPy dot star rand star, and oops, maybe that won't work, but I can do help on that, and it says, oh, it has NumPy random. What if I remove it to just ND? There we go. Now we have all these ND functions, as well as expand, around, all these functions that match. So it's a really cool way to interactively explore. It's essentially building IntelliSense and hints and the type of things that are in an IDE into this terminal interface. All right, so Python command interpreter versus the Ipython command interpreter. And now you can see we can execute this, import NumPy as MP. So import loads the package, as gives it an alias, and this is a common usage. You'll see that import NumPy as NP. And then all this is doing, this fancy thing, is it's initializing a dictionary. So if I run this, I'll see what happens, and you can see I've already ran it, and it shows me my output. It creates that. Next thing we want to do is we don't want to be stuck inside the notebook. So let's go ahead and grab this content and run it in our NumPy shell. And you can see data equals that. Now, let me just break this down for you. We're essentially doing for I in range, right? And then I can do, I'll just break it down really simply. Print NP random rand. And now you see I have options. I have rand int, rand n, which is what it uses. What I want to use is I want to use rand int, because what it does is it prints integers. So this will choose numbers from 1 to 10. And then when I execute that, it chooses a random set. And you can see it's different each time. Another interesting thing to know is I can do np random dot, I'm going to hit tab, dot s tab. I want to do seed. I can seed my random number generator. You would typically use some random input like the time to make that unique. But say you want to duplicate a random sequence. It's going to be a random sequence, but the way it initiates this random algorithm is seeded with this with the number 10 in this case, which is going to be fixed. So now I can run through and I'll create this random list 940 whatever, and then I'll run it through again 890 all that. Now if I go back here and I reset my random seed, I can duplicate that 940 890 just like last time. So this is useful to know for a couple things. Number one, if you have a random seed that's not random, it's going to duplicate the results, which may invalidate your equations if you're depending on random input and you're not setting a random seed that is random each time. But on the other hand, if what you really need is just some random data set, because you need a data set to build a scatter plot or something like that, you can actually reseed it with a known value and duplicate those same steps. So you've got a bunch of random inputs that can be reduplicated. So that's the cool thing about random seed. Okay, we'll take a minute. Do you guys have any questions? Are you following along with that pretty good?
No, it's fine.
Okay, great. So I wanted to great. I want to show one more thing about Jupyter. I want to add a new code block. You can see what it did is it created this in, and then I can, what I'll do is I'll just grab this here and I'll just type it in for I in range 1, 10, print, I. That's good enough for there. And now, so what I'm doing is I'm taking this existing notebook and I'm adding new code to it. Oops. A little too much Python 2. There we go. Now it prints this random range. One more sidebar. Range is inclusive of the first number and exclusive of the last number. So I'm not sure. It's been a while since I've done any stat stuff, but your stats sequence notation, I think, would look like this. Like it's inclusive with a parenthesis and exclusive with a bracket. Let's look at that to see if I'm right. Series, I want series, not sequence, but I don't want fancy notations. Let's see. I'll figure it out. Anyone remember their high school math? Okay, parentheses and square brackets can be used.
I remember inclusive. With a square bracket is inclusive. I remember.
Okay, square bracket is inclusive and round bracket is exclusive. Is that right? The inclusive, yeah. So I had it backwards. Square bracket is inclusive. Round bracket is exclusive. Python doesn't know that because it uses square brackets for array index. But anyway, yeah, that was just a sidebar to note from math. Thanks for that refresher. I was confident enough to bring it up, but also confident enough to get it wrong. Confident enough to get it exactly backwards. But so just to know, a Python range is inclusive of the first element and exclusive of the last. That's going to come up a lot in doing this, in doing data analysis. So that's something I wanted to bring up now, and go ahead and forget about it, but remember it later. Okay, so we've run our Jupyter notebook. It talks about tab completion, introspection. This is just the help, doing that question mark as a shortcut for getting you the help. And then we've got here def add two numbers returns APSB. Oh, so this is showing me, it's doing the same thing. It's showing you that it can have help documentation on a function that you create yourself. Two question marks is parentheses. I kind of jumped the gun. We could have read this all in the notebook and got through that. Wildcards for either functions or inclusions. Run command, %run, and you can also see here that run hello world. It guesses that you might want to put the parentheses for the magic command for run. So like I said, it first checks the magic commands. So something in the magic or in the ls magic. See, it says auto magic is on, % prefix is not needed for line magics, and the same thing for magic. There we go. And the way this scrolls is like, it's like using less from the command line. All right. I wonder how less would work from inside Ipython. Looks like it works as normal, just like a help. Okay, so run can run a command or a file. This is something that's really cool in Ipython, because if you're used to using the Python interactive shell for experimenting, and then you want to go to a file, you've got to switch back and forth between two terminals to do it. But using run, you can do it inside Ipython. The clipboard, oh yeah, so sometimes because Python is sensitive about indentation, you run into troubles. So if I hop over to Ipython here and I paste that, that worked okay. I'm trying to look for an example where it doesn't work. Oh, there we go. So you can do %paste to copy from the clipboard if for some reason your clipboard is going to screw up your indentation or something. So you can use paste or cpaste as a magic command. .paste will just get what's in my clipboard, right? If I grab this from the clipboard, oops, %paste, and that's going to give me an error just because it didn't get to it. All right, so yeah, we're just going through. Oh, another magic command is time it. This is really useful because when you're creating data science algorithms, you really need to be sensitive. If your algorithm is inefficient, it'll let you know. So just to run this example, first we can run it. Well, I guess we can't run that one, but we can run it from the terminal. Excuse me, because that's cutting and pasting. All right. So time it will run your sequence a whole bunch of times. And you see it ran 10,000 iterations of this command. And it shows an average of 136 microseconds plus or minus 4 microseconds. Standard deviation of 7. So time it is a way to benchmark your functionality and see if something's going wrong, right? If you have something that takes a lot longer than it should, especially if you're crunching millions of numbers, you're going to try your algorithm on a small data set, and then you want to time it to see how it performs, so that when you run it against your millions of items data sets, or when you run it in a stream, you know, thousands or more times a day, you know, if you are crunching a million numbers 1,000 times a day, a millisecond difference can really add up. So you can measure that. So if the time is longer than you expect, or if the variation in the time is high, that may be another smell for a problem. All right. Debug can activate the interactive debugger. I've never done that, so let's try that example. Oh, it shows PWD. You can execute shell commands. You can return the result. So in the shell, you might do something like backtick ls, and then get that in a shell command, right? And that would return that. Now that's not going to work in Ipython, but that would work in the shell. But in here, I can do my list is %ls, and then lst. Wait, what did I do it wrong? Yeah, that didn't. Let's try. So that works. I don't know why it didn't work for ls. I guess because it's not a single string output. What if I did lst equals bang ls? All right. I don't know why it doesn't work for ls, but you can get the input if it's normal input, if it's standard IO, I guess, or a single line. So matplotlib, that's pretty cool. That is the graphing library. Okay, so I need to remember I can do conda or %conda install matplotlib. And I'm going to go ahead and proceed. So now I don't have to exit my Ipython, and I'm installing this library and its dependencies, which is pretty cool. You may need to restart the kernel to use updated packages. So it's saying I may need to exit out anyway. We'll see.
Aaron, I have a question.
Yes.
If I install, for example, matplotlib using %pipe, it assumes that am I using that local environment, or it will install in the global environment of Python?
It depends. So if you launched Ipython from your specific Conda environment, it will install it in that Conda environment. If you are not within an environment, it will install it either globally or within that pip environment, or however it's installed. So it depends on where Conda is executing or where pip is executing. If you install it from in Ipython, it'll do the same you would expect from installing it in the shell. So building the font clash, that will take a minute. So, and it's going to say eventually, oh, Qt4, that's the graphics library. Qt4 is what the Linux KDE environment is built on. So Qt is a graphics library. And then when we do inline, I think, it doesn't even have the cool example where it will show us that it will run a graph. we should look at a simple example and do that to end the day. All right, we don't need to go through Python basics, right? Indentation, not braces. In other words, Python uses indentation to mark blocks, a for loop, an if block, a function, a class. It's not strongly typed. It use duck typing. It can infer typing. You guys don't want to go through Python basics today, right? It can use Unicode characters. It can cast from integers to floats and so forth. Let's get to the cool stuff. Let's draw a chart. All right, so I'm going to hop back over. Let's see if oh, here we go. We can go back to my home page. So I'm going to open up chapter 3. What I want to do is end on a high note showing matplotlib. Okay, using matplotlib. I just want to get like a simple chart, you know, do a scatter plot or something. Okay, so here we go. Let's just copy this pyplot. So again, I can do tab matplotlib dot. I'll do yeah. I'm not going to try and use that pyplot. I know what I want. Import matplotlib pyplot as plt. We've already got Numpy, right? Yep. So I'm just going to copy this to create a chart. Ta-da! And then it pops up a figure. I can also do something like t equals numpy random, or let's do it this way. X equals numpy random randint 1, 10. Oops. I want to create an array. Nope, that's not what I wanted. All right. I'm having trouble doing the match. So what I'm going to do is I'm going to do x equals list, and then I'm just going to do for I in range 1, 10, 0, 10. And then I'm going to do x append mp dot random rand int, and it'll be of range 10. All right. So now we have x, and now I want to do the same thing for y. Y equals a list, and then y append. Oops. Go to the end of that line. So now I have x and y are both a random list, and then what I want to do is I want to plot that. PLT plot x comma y. Why didn't it show? Oh, it did show. It's hidden behind it. There we go. So here's my random plot, and it actually has them both on the same graph. It has my sine wave and my random plot. And I can do the same thing, like do the same thing with x. So now that x and y will both have 20 elements, and y. And then I will go back and I'll plot x, y again, and it'll create a different color of my cool random plot of lines. So let's see what else they're doing here. Oh, it's adding labels to this. This is the fun part. Let me just, here, I'll just go back here, recreate this. Oops, that's right, I just unimported it, didn't I? There we go, we've got our sine wave, and then we can add these labels and title and so forth, and it will show it. So we have voltage, about as simple as it gets here. And I think hide is the opposite of show. Nope. Remove. Yeah.
And you generate a PNG file of that.
Say it again.
Video.
PNG what?
No, that you generate also a file, a PNG file of that graph with its name is test.png.
Oh yeah, yeah. You're just pointing out that it did that. So if I do an ls here, I have test.png, and I can go here to Finder and go to training. And oops, data science book or PyData book under here, and then we've got test PNG. Yeah, so it saves that to a PNG. That's a good thing to point out. I wasn't even reading the source code, I was just cutting and pasting it. But yeah, that's very cool. All right, so that's a quick introduction to what matplotlib can do. So let's go back through and make sure we didn't miss anything in chapter 2. So yeah, everything else it's going through in the rest of chapter 2 is just introducing some basic Python concepts. We can go through that if you want. I wasn't planning on it. I was just planning on introducing stuff as we go. So for instance, we have a for loop for I in range. We've done that several times. So both of you, I guess it's good to ask, what is your programming experience level and what is your Python experience level? So in general, programming, you're good, or you're starting out, you're intermediate, advanced?
Go ahead.
Okay, thank you. Aaron, I am just starting now. I have done some programming in C before.
Okay.
For Python, it's totally new for me, so I am just trying to grab it. And
okay, so
basics.
For you, going through the Python basics might be useful. But you understand the concepts of loops, if statements, arrays,
those I know. Yeah.
or in Python as they call them, lists. You understand what they're doing. Python is a really easy to understand language. The trick is knowing what it is. But once you see it, it's really easy to tell what's going on, right?
Yeah, that's correct. So I'm aware of if and loops with C. So I think it's quite useful for me while going through that.
Okay. So yeah, I'd encourage you to just go through this chapter 2 and go through the Python basics section here, which is like in the last half or more of this. But what I wanted to get through today was we're working both in the notebook where we can execute code sequences right here in the notebook. So you can see here, I executed A, I executed B. So A is a list. You can think of it as a dynamic array, 1, 2, 3. B, it assigns the value of A to B. And then I run A append number 4, and the output is 1, 2, 3, 4 of B. So it shows that B is actually similar to A. I can create a new block here by clicking on plus, and I can print B and execute that. You can see B is, you can think of that as a reference to A in C lingo, without the need for messy pointers and malloc and all of that. So that's kind of cool. Append is, you saw I did that when I created my random list for X and Y, right? That jumping back in here. What I do here is for I in range, you don't have to declare a variable or specify its type in Python. It will dynamically choose. So it creates this range, 0 to 10. Let's just break this down, right? Range is a function. It returns a range object. And so, for instance, I can get index 1 of this range. 1 is not in range. Oh, I did range 0, 0. I thought I did 0, 10. There we go. So R equals a range, right? If I do type of R, it's a range. I can get elements from it. So I have, right, but it's a range, it's not a list, which makes it iterable. So you can iterate over the range, but I can get these, right? I can get the count or the size. Wait. R.count, return the number of O. So it says, it counts the number of 3s in this sequence, which is 1. Okay, it doesn't do exactly what I thought. Index will give me the number at an index, right? It would. So that's a range. A range is this iterable object over a list. A list is like an array. And it has like a count. Okay, it's returned the number of values. So is it size as well? No. I can do size of L though, right? No.
For to know the length of the
length. Thank you. I'm always switching. So I can do L append, and I can add, a number to that, and I can add another number and another number. So then I can do length of L is 3. If I do L by itself, it shows I have all those. L sub 0, index 0 is 3. 2 is, and 3 or 4 will be out of bounds. It'll throw an exception or an index error. So a range can get a list, right? So I have R, and I can get the list from it. And you can see I can step through it or start and stop as like moving through a cursor. So range to list in Python. These are the type of things that are obvious. Oh, so you just cast it, or you send it to the constructor of. So I can create a list dynamically. That's the same thing as doing L equals list, right? And now there's nothing in it. But I can also do range 3 to, let's do something large like this. Let's do range 5 to 50, step 5. I believe the third argument is a step. Yeah. And you can see just by doing range question mark, optionally include step. So I can create a list like that, and a list behaves like an array. So the third one, well, the fourth one is 20. The third one, 0 index, is 15. I keep typing 3 when I want to type 2. All right. So that's how you can get a list and a range. A range you can think of as like an iterable list. Python has a lot of magic that simplifies things from C. Loops behave the same way, and that's why rather than doing for, you know, int I equals 0, I less than 10, I plus plus, that's not valid. What you would do is you just do for I in range 0 to 10. Oops, forgot the parentheses. Python 2 didn't have parentheses, and so that's, like I said in the first class, the biggest difference between Python 2 and Python 3, really. There's a lot of under the cover things, but the thing that broke a lot of modules was print. So that's how you would loop through a range. That's the pythonic way, the idiomatic way to iterate through a sequence in Python, right? And we might actually do it step 2. And Python itself, just one little last note of trivia. If you didn't know, Python is actually named for the Monty Python sketch comedy troupe. So there are a lot of in-jokes. Python being a snake. I don't even remember what snake is in Python, but it's common. Anaconda. You can see anaconda itself. So anaconda is a type of snake. There's a lot of puns like that. And it talks about the Python idiom. I can't even remember the sketch, but there's a sketch where they talk about, I don't think it's a sketch. I think it's in Monty Python and the Holy Grail, where King Arthur is looking for his idiom, right? Yeah. Yes. So Python is a language with a sense of humor, and it's a warped sense of humor because it takes off from people who like Monty Python sketches, which is definitely very warped humor. So I'll leave you on that note since we're at the end of the hour. And I need to brush up on my Monty Python humor to include more of that in these classes. Because I don't even remember what the joke is about King Arthur's proper idiom. The way he walks, maybe, with his trotting coconuts. I don't know. Anyway, too much of a divergence there. Thanks, guys, for coming. Wasn't a very big class, but hope you got something out of it. And next week we will explore Numpy. Particularly, we've looked at ranges here. NP has arrays that are like lists, and ranges, an NP range and an NP array that are similar, but they're designed to be efficient over large groups. So that's what we're going to explore next, is how Numpy has these functions like an NP list that is different than your typical list for reasons of performance. Anyway, take care. You guys have a great weekend, and we will see you next week or in the other class. If you if either of you are in the Docker deployments class, I'm not going to have that class tomorrow because I have a doctor appointment that's going to take all day. So take care. Have a good night or day, whatever your time
Thank
period.
you very much, Arun.
All right.
Thank you so much.
Bye, guys.
Have a good day. Yeah.